In this chapter, we will be studying trigonometry. In this lesson, we're going to go through a bunch of application problems. Okay, hi everybody. Now for our next lesson in trigonometry here, we're going to take a look at applications. And actually, this is where we're going to spend a fair bit more time working through the trigonometry and working through the problems here. You might have noticed in some of the previous lessons that we've gone through that we've moved pretty quickly through the material with not a lot of examples. This time around, now that we're going to take a look at these problems, they're not going to be categorized. It's going to kind of be up to you to interpret the problem and then figure out what to do with it. Now we're going to do a bunch more examples so that you've got something to work from here. Now, before we get into the applications, just some vocabulary that I got to make sure that you understand here. I need you to understand what's meant by angles of elevation and angles of depression. Okay? Now, this is all about you. You as the observer. Okay? So, an angle of elevation is going to be when you are looking forward and you have to tilt your eyes or you tilt your head up. Whatever angle you have to tilt your head up here, that's the angle of elevation. It's always measured from the horizontal up. Okay? So here we go, is the angle from the horizontal to your line of sight, but upwards to your line of sight. Angle of depression is when you go from the horizontal and you bend your head or you bend your eyes down. Okay? And so the angle of elevation, angle of depression, they're always measured from the horizontal. It's just in this case here with angle of depression, you're going down. It's never measured from the vertical up. Okay? So sometimes you're going to see situations where you're going to have something described here. It's never this angle down here. It's always going to be this one right here when we start talking about angle of depression or angle of elevation. It's always going to be from the horizontal up. Never this angle that's between your line of sight and the vertical. Okay? Now, that's not to say that we won't give you questions where we do give you those angles. Okay? But when we talk about angle of elevation, angle of depression, we are not referring to those. Okay, I know I've said that a lot here, but anyway, it's something that's important. You got to make sure that you're clear on that. Okay, well, let's jump in. Let's start doing some problems. All right, so our first example says the string on a kite is 120 meters long. So here's our diagram here. And the diagram, it's always a good idea to have a diagram. It's so important. So here's 120 meters. And it makes an angle of elevation of 42 degrees with the ground. You know, I really didn't have to say with the ground, but we know that this is going to be 42 degrees. So that's important. That's our reference angle. When we start looking at opposite, adjacent, hypotenuse, whatever, we're going to use that as our angle to help us define those. So calculate the height of the kite. We'll call that h here. Okay, and express your answer to the nearest tenth of a meter. Okay, so here's our angle. We are looking for the side opposite the angle, and we know the hypotenuse. So we know we're looking for opposite, and we know the hypotenuse. So I got to think, what trig ratio puts those together? So I write out my SOHCAHTOA, and right off the bat I see it, it's going to be sine. So here we go. So the sine of the angle that I'm given, 42 degrees, is going to equal the opposite over 120, the hypotenuse. Now, because the unknown, is in the numerator, and I know the denominator, I'm just going to multiply that straight up. So 120 multiplied by the sine of 42 degrees will equal h. And so h is going to equal, and I'm going to use approximately here because I'm going to end up having to round. But here we go. 120 times the sine of 42. And we get 80.3 when we go to the nearest tenth of a meter. 80.3 meters. That's how high the kite is. Now for the next question here, we read, Bill is renovating his house. He braces a wall with an 8-foot wall brace. Okay, so here's the wall. This is going to be 8 feet. Okay, and we can use the little apostrophe there to mean feet. So the distance from the wall to the brace on the floor is 2.4 feet, so 2.4 feet. Calculate the angle at which the brace meets the wall. Okay, that angle right there, and express your answer to the nearest degree. Okay, so this is the angle that we're looking for. Now notice in this case that it is the angle between this line here, and the vertical. So that's not an angle of depression or an angle of elevation. So just to be clear. But, we're free to ask you for that. This is the reference angle, though. So this 2.4 feet is going to be the opposite side, and the 8 feet is going to be my hypotenuse. So I've got the opposite and the hypotenuse. Okay. SOHCAHTOA. Which trig function is that? Well, again, it's going to be the sine. This time I don't know what the angle is, though. Now I'm going to use a variable here. Let's use theta. Theta is a good variable to use for an angle here. So the sine of that unknown angle is theta, and that is going to equal 2.4 over 8. Now, in this case, I don't know what the angle is, so what I got to do here is use my inverse trig function to go from the from the ratio back to the angle. So remember, we always use that inverse trig function when we're going back to the angle here. So now I pulled my calculator over. It's second sine, because I'm looking for the angle, 2.4 divided by 8. It's my opposite divided by my hypotenuse. And when I press enter, I get 17, to the nearest degree, 17 degrees. Okay, so it's approximately 17 degrees. And you know what? That makes sense. Okay, that opposite side is quite a bit smaller than my hypotenuse. I feel pretty good about that as an answer. Right, our next problem here says Mary wishes to determine the height of a tree in her yard. She measures the angle of elevation to the top of the tree to be 25 degrees. Okay, so that's going to be this angle right here, from the horizontal up to the line of sight. And the tree we're going to assume is perpendicular to the ground, at a point 20 meters from the base of the tree. How tall is the tree to the nearest tenth of a meter? So let's call that h. All right, well, here's our angle, and that's going to help me define. The h is going to be my opposite. That's what I'm looking for. And down here, this is going to be my adjacent. So now, what trig functions put together opposite and adjacent? So it's going to be my tangent, my TOA. So then I come over here and I'm going to write the tangent of 25 degrees. That ratio should be the opposite side divided by my adjacent 20. And I love the fact, once again, that I've got the variable up in the numerator, because that means I can just write 20 multiplied by the tangent of 25 degrees. Okay, bring out the calculator, and I'm going to write 20 tangent of 25. And I get to the nearest, tenth of a meter, 9.3. So 9.3 meters. And I use the little dot over the equal sign because I had to round, so it's just approximately true. In this problem, we read that Matt is 1.65 meters tall. Okay, so 1.65 meters. And his shadow is 1.43 meters long. Determine the angle of elevation of the sun. Okay, so this is important because we're leaving it up to you as the person doing the problem to determine which angle this is that we're looking for. Now we're assuming that Matt is going to stand perpendicular to the ground, but is it this angle up here or this angle down here? And remember that anytime we talk about elevation or depression, it's always up from the horizontal or down from the horizontal. So it's going to be this angle right here is the one that we're looking for. So this angle here helps me define the sides. This side over here is going to be the opposite to that angle. This side down here is going to be the adjacent to that angle. So I've got opposite and adjacent. I write out my SOHCAHTOA so that I can figure out that it's TOA, tangent. So the tangent of that angle theta, and I don't know the angle, is going to be 1.65, the opposite, over 1.43. So I have the ratio. I need to go back to the angle. So remember, tangent won't do that. But the inverse tangent will do that. So it's going to be the inverse tangent. Okay, the inverse tangent of 1.65 divided by 1.43. And I get to the nearest degree. This is approximately equal to 49 degrees. Now, in this problem, we read Joel is flying a kite. He lets 150 meters of string go. Okay, so that's going to be the hypotenuse there. And using a clinometer, he measures the angle of elevation of his kite to be 75 degrees. So angle of elevation, so from the horizontal up, 75 degrees. How high is the kite above the ground? There we go. So what have we got? Well, here's our angle. That's the angle that's important here. This side here, the height, is going to be the opposite. And because that 150 is opposite the 90 degrees, this is my hypotenuse. So SOHCAHTOA. I have opposite and hypotenuse. That's going to be sine. So it will be the sine of 75 degrees is going to equal the h over 150, the opposite over the hypotenuse. Now, love having that unknown up in the numerator, because now I just have to move that 150 up and make it 150 multiplied by the sine of 75 degrees. Now, notice, I'm not going to use the inverse sign here because I know the angle. Okay? When I know the angle, I can just use my regular old sine. Sine of 75. So the angle goes in there. Then I multiply that by 150. And what is that? I want to know to the nearest meter. So this time I'm going to round to the ones position. So it's going to be 145. So this will be approximately equal to 145 meters. So in this next question, we read that a peregrine falcon has built a nest on the ledge of a building in Calgary, Alberta. The ledge is 34 meters from the ground. Okay, so it's going to be up here, so 34 meters. Elaine wants to take a photograph of the bird with his telephoto lens. He has set his camera up waiting for the bird to return to the nest. His camera sits on a tripod 2 meters above the ground. Okay, now that's interesting, because what that means is that our triangle starts 2 meters above the ground, which means this 34 meters that I have in my triangle, that's actually not true. My triangle doesn't go right to the ground. My triangle starts 2 meters above the ground. So this side of my triangle is actually going to be 32 meters. I'm going to lose 2 meters because I'm taking the bottom of that triangle and sliding it up just a little bit because of that tripod. Now the angle of depression from the nest to Elaine's camera is 28 degrees. Angle of depression is from the horizontal down. How far is the tripod and the camera from the building? So what I want to know here is I want to know this horizontal distance. This is a good question because it's not giving you the information exactly the way we've got it in the last previous questions. So, for example, I don't have an angle in the triangle. But I do have this angle of depression right here. Now, that's not in my triangle, but to go from the horizontal and rotate all the way down to the building, that's 90 degrees. So if I want to figure out what this angle is right here, if I just go 90 minus 28, I've got 62 degrees right there. So in my triangle, there's my angle, 62 degrees. And that helps me define things. I know that this side down here that I want is the opposite. And the side right next to here, that 32 meters, remember, that's the part that's in the triangle. Okay, it's not 34 because I'm not going right down to the ground. I'm just going up to the level of the camera here. But that's going to be my adjacent. So I've got the opposite and the adjacent. SOHCAHTOA. That's going to be tangent. So the tangent of 62 degrees will equal the opposite, x, over the adjacent, 32. Love having that in that position because it's just a matter of multiplication. 32 times the tangent of 62 is x. So 32 multiplied by the tangent of 62, and it says to the nearest tenth of a meter, so I will going to round that to 60.2. Okay, so 60.2 meters is how far away that camera is from the base of the building. In this question, we read that from the top of a 30-meter lighthouse, okay, so 30-meter lighthouse, that's It's that side right there. A boat is observed at an angle of depression of 27 degrees. So that means looking out, we have to tilt down 27 degrees to see the boat. Determine the distance from the boat to the lighthouse, so this distance right here, to the nearest tenth of a meter. Oh, sorry, to the nearest meter, I should say, just the meter. Let's call that x. Okay, well, once again, I don't have the angle in the triangle. I've got this angle of depression out here. To get the angle in the triangle, I might go 90 minus 27. And I get 63 degrees right there. Good. So there's my angle inside my triangle here. And that's what's going to allow me to define the sides. I know that the side over here is going to be the opposite side. And I know that the side over here, the height of the triangle, the height of the lighthouse really, is going to be my adjacent side. SOHCAHTOA. So which one puts together the opposite and the adjacent? Tangent. So the tangent of 63 degrees is going to equal the opposite, x, over the adjacent, 30. Okay, I can now just multiply up that 30 meters. So just multiply it by the tangent of 30. Okay, so it's 30 times the tangent of 63. And I get 58.878, blah, blah, blah. But to the nearest meter, I would round that to 59 meters. And that'll be approximate. And there you go. In this problem, we read that the base of a ladder is on a level ground 1.9 meters from a wall. Okay, that's going to be down here, 1.9 meters. The ladder leans against the wall. Okay. The angle between the ladder and the ground is 65 degrees. So this angle right here is 65. That really is the angle of elevation of the ladder. Give your answers nearest tenth of a meter. Okay, so how far up the wall does the ladder reach? So I'm looking for this distance right here. Let's call that x. So here's my angle. The side that I want is opposite the angle, and the side that I'm given is adjacent to the angle. So at this point right here, you're probably kind of getting used to what I'm doing here. I'm setting up my little SOHCAHTOA, and you've probably noticed at this point that a lot of these things are coming up as tangent. The answer is yeah. In a lot of cases, in a lot of scenarios that we would set up for you, finding the hypotenuse or incorporating the hypotenuse is not always the easiest thing to do, but it's usually relatively easy to find one of the legs of the triangle. So here, we're going to set this up as the tangent of 65 will equal x over 1.9. And now we multiply up by the 1.9 times the tangent of 65. Bring the calculator over 1.9 times the tangent of 65. And to the nearest tenth of a meter, I'm going to get 4.1 meters. And that's only going to be approximate. Now, the next question asks, how long is the ladder? And see, now, here's an example of a question where I am now looking for the hypotenuse. So in this case right here, we can now ignore that opposite side. Now what I'm looking for is the hypotenuse, and I'm still going to go back to the adjacent. So this is a nicely set up for using something other than tangent. Okay? And so what trig function here puts together the adjacent and the hypotenuse? And the answer is cosine. So the cosine of 65 degrees is going to equal the adjacent 1.9 over y, the hypotenuse. Now, notice in this case here that this one's a little different because the thing that I'm looking for, the unknown, is in the denominator in this expression. But remember, I can swap those two. Okay, I am totally allowed to swap those two. So now, instead of multiplying, I'm actually going to do the division here. So now what I get is 1.9 divided by the cosine of 65. And to the nearest tenth, I'm going to get that to be approximately 4.5 meters, whatever units that ended up being. Yeah, meters. Okay, in this problem, two office towers are 50 meters apart. Okay, now that's an important bit of information. Now that's probably measured down here, 50 meters apart, but we're going to assume, and we have to assume, that the buildings go straight up, meaning that this distance up here is also going to be 50 meters. Okay, so that's an important kind of translation of that value up to the top of the building here. Now, from the top of the shorter tower, the angle of depression to the base of the tower, the taller tower, is 35 degrees. So that's from here down, angle of depression, 35 degrees. The angle of elevation to the top of the tower, okay, so it's from here up, it's going to be 25 degrees there. Determine the height of the taller tower. Well, what I've done to the height of the tower by drawing these two triangles is I've really broken it up into two different triangles. So, I don't know, let's call this distance here x, and we'll call this distance here y. So the height that I'm looking for is going to be x plus y. Okay, so now I got to take a couple moments here, and I got to figure these out here. So let's take a quick look at this. So here's my angle in this triangle. So that means that's my reference angle. I am looking for the side opposite, and I've got the side adjacent. Okay, that 50 meters there is going to be adjacent to that angle. So I look at my SOHCAHTOA, opposite and adjacent. Okay, there it is. It's going to be TOA here, so tangent. So the tangent of 35 degrees is going to equal the x over my 50. And so x is going to equal 50 times the tangent of 35 degrees. Oops, sorry, I was going to put an approximately there, but I'm not there yet. So, going to my calculator, 50 times the tangent of 35. Okay, so 35.0. Okay, now I'm actually going to leave that in my calculator. I'm going to leave that number sitting right there. So I'm going to go back and pull that out here. I don't want to use the rounded version that I just came up with, because if I made a mistake in there, or as soon as I start to do math with it and I rounded it, there's a little error there that tends to get bigger. So I'm going to write it rounded to the nearest tenth, but I'm going to leave the number in my calculator. Now let's take a look at y. Let's take a look at the top triangle here. Here's my angle, and again I'm looking for the opposite, and again I have the adjacent. So once again, it's going to be the tangent ratio. So tangent of 25 degrees is going to equal the opposite, y, over 50. So 50 multiplied by the tangent of 25 is y. So 50 multiplied by the tangent of 25, 23.3. Whoops, that's approximate. 23.3 meters. It's approximately equal to y. And now I'm going to bring these numbers over, and I'm going to add them together. So this is how I'm going to do that. I'm going to first of all take this number right here. So on my calculator, I'm allowed to go up, and I press enter, and it just yanks it down. Plus, and then I'll go up to the other value that I had calculated earlier, press enter, and that yanks it down. And now I'm going to add those two together. And to the nearest tenth, I get 58.3. So this will be approximately equal to 58.3 meters. So in this problem here, we read Fred's eye level is 1.6 meters above the ground. And as soon as I read that, that reminds me of a question we did not too long ago here about the peregrine falcons, and where we took the bottom of the triangle and we moved it up. So I think that's going to be an important number here. Now, the Eiffel Tower is 324 meters tall. We want to calculate the angle of elevation to the top of the Eiffel Tower when Fred is 550 meters away. So he's 550 meters away. And we're looking for this angle right here. So that's going to define this to be the adjacent side. Okay, this 550. And then we've got the opposite side, but it's not 324 because we've moved the bottom of that triangle up. And so what's happened here is we've got this 324 over here, and then we have to subtract this 1.6 from it. Okay? And when we do that, when we take that 324 and we subtract 1.6 from it, we get 322.4. Okay, so the actual height of the triangle that we're looking at here is 322.4 meters. Now, this is going to be opposite to that angle that I'm looking for. I don't know what the angle is, but I know it's the reference angle, and I know it's making this the adjacent, making this the opposite. At this point in time, you're probably aware that that's going to be the tangent. Don't know what that is, but I know the ratio. It's going to be 322.4 over 550. And so theta, because I know what the ratio is, but I don't know the angle, I have to use the inverse tangent, 322.4 over 550. Pull in my calculator, second tangent gets the inverse function activated, 322.4 divided by 550. And what is it? Okay, I'm going to assume it's to the nearest degree. And to the nearest degree, that's 30 degrees. So approximately 30 degrees. So in this final problem that we're going to do, we've got right triangle ABC, where angle ABC is 90 degrees. Okay, so it really helps to have a diagram here. And when we label these angles here, it's the vertex, the middle variable here, or it's the middle letter, I should say, is the vertex. So this is going to be B. And then it really doesn't matter where I put the A or the C, so I'll just put the A and the C there. So angle BAC, so starting at B, BAC, that's this angle right here, is 70 degrees. And AC, oh, so there's a typo here. It's not 29 degrees. Let's say 29 meters. So AC is going to be 29 meters here. Now, for me to get the perimeter, what I need to do is I need to add up all three sides here. So let's call this side over here X. We'll call this side over here Y. I need those. Okay. Actually, you know what? So let me change those. Let's go back to one of the things that we would have learned about labeling here. If this is angle A, over here, this is going to be side little a. So we need little a. And if this is C here, over here, what's opposite is going to be little c. So that's what I want to do. I want to add those three together. To get my perimeter, I want to add A plus B plus C. But in this case here, I already know that B is going to be 29. So I'll finish this in just a second here. So let's talk about A first. So 70 degrees is clearly the reference angle. I need the opposite side. I've got the hypotenuse. So then I think over here, SOHCAHTOA. Opposite and hypotenuse, that's my sine. So the sine of 70 degrees is going to equal A over 29. So 29 multiplied by the sine of 70 is going to equal A. So let's go through and do that. So 29 sine of 70. Okay, and we're looking at 27.3. 27.3 is approximately equal to A. Now, let's not worry about that. We've already got A. Let's take a look at C. C is going to be adjacent to the angle. So what trig function puts together the adjacent and the hypotenuse? Well, that's my cosine. So the cosine of 70 degrees is going to equal C over 29. So 29 multiplied by the cosine of 70 degrees is C. So 29 multiplied by the cosine of 70 degrees to the nearest tenth will be 9.9. And again, I'm assuming, let's say, meters here. So meters. That's approximately equal to C. So now, to get the perimeter, I'll add 27.3 plus 29 plus 9.9. Okay, and this is approximate because I have to round in there. But now let's go through and do it. And so this is what I'm going to do here. I'm going to use my little arrow key. I'm going to go up. I'm going to grab the 27.3, add the 29, add my C value, and I get 66.2, meters as the perimeter of that triangle. Okay? So I hope with all these examples here that this gives you a good sense of how to approach these types of trigonometric problems.